Welcome to the deep dive. Today we're really setting off on a bit of a journey, aren't we? Looking at these sources you sent over.
Yeah, it's structured less like analysis and more like a voyage, starting right here, from Earth and heading out.
And it kicks off immediately with this big contradiction.
It really does. It forces you to think. We see Earth as, massive, all these countries, billions of people, endless stuff going on.
Absolutely, it's our whole world.
But the source just lays it out there in the grand scheme of things. Earth is very small, like way smaller than you'd probably guess.
That really sets a humbling tone right from the start. It's like, okay, let's recalibrate everything we think we know about scale.
Exactly. And the idea is, as we pull away from Earth in this journey, we're traveling back in time, looking for points we never even conceived of, trying to figure out the bigger picture.
So where do we start this cosmic trip? Not some distant galaxy, right?
No, we start close, really close. Our first stop, the first station, is the moon.
Our nearest neighbor. Makes sense. It's always been there, dominating our night sky, our myths.
Our culture, everything. It's the only other place we've actually walked, so it's the logical first step outwards.
Okay, so let's talk about that close. We know it takes, what, 3, maybe 4 days for a spacecraft to get there?
Right. Relatively quick trip.
The official distance, the number, is 0.384 million kilometers. But numbers, they don't always paint the picture, do they?
Not even close. And here's the bit that really jumps out from the source. The aha moment, if you like.
Okay, hit me with it.
That gap, that space between us and the moon, even though it's only a few days' travel, it's so vast you could fit 30 Earths side by side in that distance.
Wait, 30? 30 whole planets?
30 lined up between here and the moon.
Wow. Okay, that completely reframes it. You look up, it seems so close, almost reachable, but 30 Earths. That's just empty space, a huge void.
It makes you appreciate the engineering and, frankly, the guts involved in the Apollo missions even more, doesn't it?
It really does. Suddenly, that small step seems like a giant leap across an almost unimaginable gulf.
Precisely. And it sets up this idea of the moon as, like the source says, this round-shaped stone, this object of dreams for millennia. But before we get into the science of crossing that void, we need to talk about what was already on the moon, at least in our minds.
The myths, the stories, right? Science often has to clear the ground first, doesn't it? Push aside the folklore.
Definitely. And we all heard them growing up. I mean, the classic one, the source mentions it too, is the old lady on the moon, sitting there weaving on a spindle forever.
Yeah, I remember that one. Such a peaceful, almost comforting image. Explains the patterns we see.
Exactly. A way to make sense of the light and dark patches. But then reality arrives. July 24th, 1979, Neil Armstrong, Buzz Aldrin, they land.
No old lady.
No old lady. No spindle, just rocks and dust. 6 more missions followed. Same result. Science, it took away a beautiful story, but it gave us the actual geological truth.
Must have been a bit of a shock. Culturally, worldwide. But the old lady wasn't the only resident up there in our stories, was she? The sources mention another really striking one.
Oh yeah, the tale of the sacrificial rabbit. This one's fascinating because it wasn't just a fireside story. It was apparently part of the school curriculum in Japan until, the last century.
Really? Taught in schools, so it carried a moral weight.
Huge moral weight. It's presented as a test of virtue.
Okay, set the scene for us. How does this test unfold?
Right, so you have Sokka, the god of the skies. He disguises himself as a frail old man, shivering, wrapped in a sheet, tending a small fire in the jungle.
Playing the part of someone weak and needy.
Exactly. He spots 3 animals playing nearby, a jackal, a monkey, and a rabbit. He calls them over, says he's starving, near death, and asks them to find him some food, testing their compassion, essentially.
And how do they respond? This is where the character test comes in, I guess.
Precisely. The monkey, being agile, shimmies down to a stream, catches a fish, brings it back. Quick and effective. The jackal, though, is described as lazy and a bit dim. It just scavenges around, finds a lizard, and offers that. Better than nothing, maybe, but not exactly heroic.
And the rabbit?
The rabbit tries its best, hops around, searches everywhere, but finds absolutely nothing the old man could eat. It fails the task.
So it comes back empty-handed? What does it do?
This is the core of the story. The rabbit, feeling it has failed, shows what the source calls extreme humbleness. It speaks directly to the old man.
What does it say?
It says basically, oh, good old man, I couldn't find anything for you, so eat me instead, jump into the fire, cook me, satisfy your hunger.
Whoa. It offers itself.
Without a second thought, and it jumps straight into the fire, an act of total self-sacrifice.
That's intense. especially for a school lesson. So what happens? Does Sokka let the rabbit burn?
No, Sokka immediately drops the disguise, reveals his true identity as the Sky God. He explains he was just testing them. He pulls the rabbit out of the fire, completely unharmed.
Okay, so a reward for its virtue.
A permanent reward. To honor its sacrifice, Sokka takes the rabbit's image and places it permanently onto the face of the moon.
Ah, so that's another explanation for the patterns we see. The rabbit's shape.
Exactly. And the idea was that this image would serve as an example of virtue till end of the world. The source makes the point that, stories like these were powerful. People who were, let's say, shy of research, they held on to these images. They sought a face on the moon that matched their chosen story.
It's easier to see a rabbit or an old lady than, well, the reality. Which brings us to the science. If it's not a weaving woman or a noble rabbit, what are we actually looking at up there? What makes those shapes?
It's pure geology, nothing figurative about it. What we're seeing is the result of billions of years of intense volcanic activity. It's basically lava and ash.
Okay, let's get into that geology. The Apollo missions brought back samples, right? Rocks.
They did, and analyzing those rocks, those pieces of the moon, confirmed it. Around 3.5 billion years ago, the moon was volcanically hyperactive.
So not the quiet, dead world we see now.
Not back then, no. Countless volcanoes erupted. Lava flowed like rivers, spreading for thousands of miles across the surface.
And that lava cooled down.
Exactly. It cooled, solidified, and formed these huge, flat, dark plains. Those are the dark patches you see from Earth.
And those are the features scientists called the seas, the Maria.
That's them, Maria, Latin for seas. It's a bit of a historical hangover from when early astronomers peering through basic telescopes genuinely thought they might be looking at oceans or vast, dry seabeds.
A poetic name, even if inaccurate. Sea of knowledge, sea of crises, sea of cold.
Yeah, the names are evocative, but chemically they're mostly basalt. Dark, dense volcanic rock, rich in iron.
Okay, that covers the dark areas, the seas. But what about the rest of the moon, the brighter parts, the highlands?
Right, the lighter areas, you could call them deserts or highlands. They look rugged. Their composition is totally different from the dark Maria.
How so?
These are mostly made of the ashes and ejected material from those massive volcanic eruptions and, crucially, from countless asteroid impacts over billions of years.
Ashes, like volcanic ash.
Sort of, yeah, but also pulverized rock from impacts. The dominant rock type here is called a northocite. It's much lighter in color and less dense than the basalt in the Maria.
And that lightness explains why they look so bright from Earth.
Absolutely. The source says the ashes landed on the hills like snow. A northocite is highly reflective, so when sunlight hits these highland areas, they bounce that light back really effectively, making them shine brightly.
So the face we see, the patterns, it's just this contrast. Dark, iron-rich lava plains next to bright, reflective highland rock.
That's essentially it, a geological tapestry woven by volcanoes and impacts over billions of years.
And that specific geology, the nature of that surface, leads us directly to probably the most famous single image from the moon landings.
Ah, the footprint. Neil Armstrong's boot print.
Yes. Why was it so perfect, so clear?
Because of that very surface we were just talking about. Armstrong didn't step onto hard, solid rock. He stepped onto those highlands covered in fine, soft, powdery ash and dust the regolith.
Okay, so the ground just gave way easily.
Perfectly. It allowed his boot to sink in, leaving a really deep, sharply defined impression. An instant, iconic symbol of human presence.
The word that keeps coming up is permanent. That footprint is over 50 years old now, but photos make it look like it happened yesterday. How is that possible?
It comes down to the moon's environment. Or rather, the lack of one. The moon has no atmosphere to speak of, no air, no wind, no clouds, no rain, nothing.
None of the things that cause erosion here on Earth. Wind, water, weather.
Exactly.
Right.
There's no mechanism to wear things down or blow them away. The environment is incredibly static, unchanging on human timescales.
It means those footprints.
They're going to stay there pretty much exactly as they were left. For millions, maybe even billions of years, they are, in the most literal sense, permanent records etched onto another world.
Billions of years.
Yeah.
That's mind-boggling. And it raises that philosophical question the source brings up, doesn't it?
It does. It forces you to think about humanity's own lifespan. Will we even be here in our current form when those footprints eventually, slowly, get eroded by micrometeorites over vast eons?
Yeah, the source mentions maybe evolution changes us, or maybe our own warrior temperament leads to our end long before then.
It's a sobering thought. But whatever happens to humanity, the evidence of our visit those footprints will persist. A silent monument on the moon, potentially outlasting our entire species.
And it wasn't just Armstrong's print, right? There were multiple missions. More astronauts walked on the moon.
Oh, absolutely. 12 astronauts in total left their boot prints across 6 Apollo missions. 11, 12, 14th, 8, 16th, and 7th. Their paths are mapped across the lunar surface.
So there's a whole network of human tracks up there.
Tracks, yes. And also the tracks left by the lunar roving vehicles, the moon buggies. Those wheel marks will last just as long. And then there's the slightly more unusual evidence.
You mean Alan Shepard?
You got it. The source mentions the golfer Shepard's smashes. He famously hit a couple of golf balls on the moon during Apollo 14.
So there are golf balls sitting up there, too. For billions of years.
Presumably, unless a future astronaut collects them. It's this amazing mix of high science and, well, human quirks. Serious exploration alongside a game of golf. Perfectly human, isn't it?
It really is. But there's one other Mark mentioned, one that wasn't official NASA procedure. It was deeply personal.
Ah, yes. The story of Eugene Cernan, Apollo 17 commander, the last man currently to walk on the moon.
This was in 1972.
Huh?
What did he do just before leaving? The source calls it a weird act.
Maybe weird in context, but deeply moving. Just before climbing back into the lunar module for the last time, Cernan knelt down in that bright lunar soil, the ashy highlands, and he wrote his young daughter's initials, TDC for Tracy Dawn Cernan, into the dust. A message left on another world for his child. An everlasting gift he intended it to be.
That's incredibly touching. A father's love note written on the moon.
He was apparently very happy to have done it, fulfilled a promise, but there's a bittersweet postscript to it. Until the day he died, Cernan regretted one thing about that moment. Amidst all the procedures, the packing up, the checklists for the last moon departure.
He forgot something.
He forgot to take a picture of the initials. He had the cameras, video was rolling elsewhere, but he never documented that specific personal mark he left.
Oh, wow. That's poignant. The last man on the moon leaves this beautiful personal trace, and there's no photo. Just the knowledge that it's there.
Exactly. It underscores the human element in all this grand exploration. Apollo 17 was the end of an era. Armstrong, the first, Cernan, the last, both gone now. But the source is clear. This isn't the end of the story.
Right, the focus is shifting now. It's not just about visiting anymore.
No, the talk now, the planning, is for a permanent presence, setting up a sustainable lunar station. The source suggests maybe within the next 10, 15 years.
And the goal isn't just science.
Science, yes, but also resources. Looking at how to utilize lunar materials potentially as a stepping stone for missions further out into the solar system. The moon as a base camp, not just a destination.
This whole future plan relies on the moon staying put. More or less. Let's circle back to its motion. Why do we only ever see one side? That same familiar face for all of human history.
The mystery of the moon's face lock, or synchronous rotation. It's a fascinating bit of orbital mechanics.
How does it work? It's not just that it doesn't spin, right?
No, it definitely spins. It rotates on its own axis, just like Earth does. But here's the key. The time it takes the moon to complete one rotation on its axis is exactly the same amount of time it takes to complete one orbit around the Earth.
Okay, so its spin speed is perfectly matched to its orbital speed.
Perfectly matched. About 27.3 days for both. So as it travels around us, it rotates just enough to keep the same side always facing us. It's locked in this gravitational dance.
Was it always like that? Did it form that way?
Unlikely. It's something that happened over billions of years. Earth's gravity is the culprit. It exerts tidal forces on the moon, creating bulges.
Like ocean tides on Earth.
Similar principle, but with rock. These forces created friction inside the moon, slowing down its initially faster rotation over vast timescales. This is called tidal braking. Eventually, it slowed until the moon's rotation period matched its orbital period. Settling into this lowest energy state, the face lock with one side permanently turned towards us.
So gravity locked it into place. Amazing. But we have seen the other side, haven't we? The far side.
Oh, yes. Spacecraft have orbited and mapped it extensively since the late 1950s. We know exactly what the far side of the moon looks like.
And what does the source say about it? Is it similar to the side we see?
Dramatically different, actually. It describes the far side as extremely beautiful and bright.
Brighter? Why?
Because it has much less of those dark Maria, the volcanic plains. The geology is different back there.
How so?
The crust on the far side is significantly thicker than on the near side. This thickness made it much harder for magma from the moon's interior to erupt onto the surface.
So fewer massive lava flows.
Far fewer. The far side is dominated by the bright, heavily cratered highlands, that reflective northocite rock we talked about. So overall, it reflects more sunlight, making it appear brighter than the near side with its large, dark patches.
It makes you wonder how different our myths and culture might have been if that side faced us. A bright, mountainous face instead of the man in the moon patterns.
It's a fascinating thought, and connecting this to current events, the source mentions a recent Chinese robotic mission. Where did it land?
On the far side.
Exactly, on the far side. It's a prime location for science because that thicker, less volcanically processed crust might hold older, better preserved secrets about the moon's formation and maybe even clues about the early Earth. They're running experiments right now.
Which brings us neatly to the moon's origin story itself. How did it get there? It wasn't always our companion, was it?
No, the leading scientific theory, the giant impact hypothesis, which the source touches on, is pretty dramatic. It suggests the moon was born from violence.
How long ago was this?
Around 4.5 billion years ago, very early in the solar system's history. The idea is that a massive object, something about the size of Mars, scientists sometimes call it Theia, slammed into the young, still-forming Earth.
A planetary collision?
A colossal one. The energy involved would be almost unimaginable. It would have vaporized huge amounts of Earth's outer layers and most of Theia itself.
And the moon formed from the debris.
Yes, a massive cloud of molten rock and vapor was blasted into orbit around the Earth. Over time, maybe surprisingly quickly, perhaps just centuries or millennia, gravity pulled this debris together and it coalesced to form the moon.
Does that explain why moon rocks are somewhat similar to Earth rocks?
It does. They share isotopic signatures, suggesting a common origin. But the moon lacks a large iron core like Earth's, and it's depleted in certain volatile elements. The impact theory explains this. The debris would have come mostly from the mantles of Earth and Theia, with Earth retaining most of the heavy core material. The intense heat would have boiled off many volatiles.
So born from Earth, essentially, and then gravity just took over.
Pretty much. Once formed, this new body started orbiting the much larger Earth, initially much closer than it is today, and the laws of physics dictated the rest, leading to the orbital dance we see now.
But that dance isn't static, is it? We mentioned the footprints being permanent, but the moon itself isn't staying in the same place relative to us.
That's right. Our relationship is dynamic, constantly changing, albeit very slowly. The moon is actually moving away from the Earth.
Gradually drifting further.
Yes. And we know exactly how fast. The current rate is about 3.8 centimeters per year.
3.8 centimeters. That's incredibly precise, like an inch and a half a year. How on earth do we measure that across hundreds of thousands of kilometers?
Again, thank the Apollo missions. Remember Armstrong and Aldrin's last job? It wasn't just packing up.
They left something behind.
They did. They deployed a device called a lunar laser ranging retroreflector, and later Apollo missions deployed more.
Retroreflector. Like a mirror.
A very special kind of mirror array. It uses corner cubes. The physics means that any light beam hitting it, like a laser fired from Earth, gets reflected directly back along the exact path it came from.
Ah, so scientists on Earth can shoot a laser at these reflectors.
In time, precisely how long it takes for the light pulse to travel to the moon and bounce back. Since the speed of light is constant, this gives an incredibly accurate measurement of the distance.
And doing this over decades shows the distance is increasing.
Exactly. By that 3.8 centimeters per year, it's one of the most precise long-term experiments ever conducted, and it unequivocally proves the moon is receding. It's a direct consequence of the same tidal forces that caused the phase lock, transferring angular momentum from Earth's rotation to the moon's orbit.
So if we play this out, 3.8 centimeters a year doesn't sound like much, but over cosmic time, what happens eventually?
Well, if it continues at this rate, the moon will appear smaller and smaller in our sky. The source estimates that after about 50 billion years, it would have drifted so far away it would barely be visible, if at all. Total solar eclipses would have become a thing of the distant past, long before that, of course.
50 billion years. Okay, that's still a comfortably long time away.
It is, and the source puts it in perspective immediately. It says, basically, don't worry too much about the moon leaving us.
Because something else happens first.
Because about 45 billion years before the moon gets that far, our own sun will reach the end of its main sequence life. It'll swell up into a red giant, likely engulfing the inner planets, including Earth.
Ah. So Earth's fate is sealed long before the moon drifts away entirely.
Pretty much. The sun cools down, Earth becomes, as the source puts it, an untold and unheard tale. Our planet's story ends way before the moon's orbital journey does.
That really hammers home the scale, doesn't it? Both space and time. So, given this inevitable end for our home system, what's the final message? The takeaway for humanity?
It circles back to survival. The source is quite direct. If the human race wants to avoid that ultimate fate, that solar demise, it has to become interplanetary. We need to learn to live sustainably elsewhere, on other planets or in space habitats.
Looking outward is not just exploration, it's existential necessity.
Exactly. But it's not just about the technology to get there. The source adds a crucial condition, a prerequisite for this cosmic migration.
Which is?
It comes down to how we behave. It says humanity must undertake this expansion with love, since love conquers all.
Love. That seems almost counterintuitive in a discussion about astrophysics and survival.
Maybe, but think back to that warrior temperament warning. The implication is clear. If we carry our conflicts, our divisions, our hatreds out into space with us, we'll likely just destroy ourselves there instead of here. To survive on the cosmic scale, the source suggests, requires a fundamental shift towards cooperation and empathy. Harmony isn't just nice, it's necessary.
So technological advancement needs to be matched by, well, social and ethical advancement if they're actually going to make it long term.
That seems to be the ultimate point derived from this journey through the source material.
Yeah, we've covered a lot, from rabbits and old ladies and myths to the hard science of lava seas formed billions of years ago.
2 footprints that will last for eons, and a moon slowly drifting away at 3.8 centimeters EM.
It really highlights the sheer scale of time and space and the almost absurd permanence of tiny human actions against that backdrop.
And that final thought about needing to move outward, needing love to survive, it sets up the next question, doesn't it? Where could we go?
Exactly. The source material we started with hinted at this bigger journey, seeking out truly alien places. It mentions searching for a place where every day is a doomsday, and get this, where the sun daily rises in the west.
Now that's a mind bender. After focusing on our familiar moon, stable and predictable, imagining a world where the sun rises in the wrong direction.
It completely flips our most basic assumptions about how worlds work. What kind of planet, what kind of celestial mechanics could possibly lead to that? It's the perfect hook, building right on the need to look beyond Earth that the source emphasizes.
A fascinating puzzle to ponder as we wrap up this deep dive. Where in the cosmos does the sun rise in the west? Something to think about until next time.